with a lesson on graphing linear inequalities. And by the end of it, you should be able to graph a linear inequality and its solution set on a coordinate plane, and you'll be able to rearrange a linear inequality into slope-intercept form. So in honesty, we've actually done a lot of the stuff that you need for this lesson. We have graphed linear equations using slope and y-intercept, and we've solved equations for slope and y-intercept form. So we're prepared for this. We're just going to add a couple of new concepts. All right. So here we go with some pictures, and sometimes a visual is the best way to learn for those visual learners out there. So this is going to help you out. Solutions to inequalities are on the solid line or in the shaded region. All points on this side make the inequality true. So let me show you what I'm talking about. If we have a word or an inequality like greater than, that means you want to shade above the line. And so what I mean by that is if I have a line graphed, then you want to shade this side of the line. So basically use your common sense to know that greater than is above, and in that area is the place where the solutions are, where the answers are. Now, if you have the word less than, that means you're going to shade below the line, because the answers to that will be found below the line, so down here, okay? And again, just kind of use common sense, less than, below, and all of this will kind of work out for you. But it's very important that you do this because you're not always going to be told to do this in the directions. All right, next up, we got these funny little faces here. Well, these faces are a great visual to help us remember what to do for these inequalities. So if it's just greater than or less than, you're going to use open circles. And that was a concept taught to you in the Nearpod on Tuesday. So if you had trouble with that, which most people did not, go back and rewatch that, or if you haven't finished it, please do, so that you can see what I mean by open circles. It does not include that number. And nor does a dotted line, which we will use whenever there is just a greater than or just a less than. So the eyes to that face are what's so important. Dotted lines, open circles for greater than or less than. But when we change it to greater than or equal to or less than or equal to, that's when the line will change. So when we've got this little line underneath here, that's when we will use a filled in circle, a closed circle, or a solid line. And again, if this doesn't really make a whole lot of sense to you, we're going to use this information and I'll come back to it and it'll certainly kind of start to make more sense as we see it being used, okay? So there you have it, a little preview of what's to come with graphing inequalities. So let's get right to it. Let's do the first one, shall we? So here we go with graphing the inequality y greater than negative x plus 3. So this has already been solved for y, and we like that because that means it's in slope-intercept form. So that means I can tell what the slope and the y-intercept is just from looking at the equation. So here we go, and this was the very first lesson in this marking period, lesson number 9. So if you haven't done that Jamboard, here's your chance to kind of relearn how to do this. So the number in front of x, if there's nothing there, is always a 1. So in this case, a negative 1 because it's negative x. Now I can change that so it's a rise over run by putting it over 1. So this makes the rise, and this makes it run. So now you have a slope. But you can't use that slope unless you know where to start, the initial value, otherwise known as the y-intercept. And that's always the number that's all by itself, so the 3. So I'm going to graph this line on the coordinate plane, but I got to remember a few things. Because this symbol is just a greater than, I'm going to go back to the little picture we had and see that it's over here, greater than. It's an open circle and it uses a dotted line. So from our visual, we're going to use open circles and dotted lines. and I'll explain why in just a second. So start at 3 on the y-axis. Remember, your y-intercept is your starting value, up 3. And now I'm going to rise 1, but -1, so down and right 1. Down 1, right 1, down 1, right 1, down 1, right 1. Some of you are really good at graphing lines, and you use that slope, and you look at it and say, is that a negative slope? Is it going down? Is it going to the right? Yes, it is. Now connect these points with a dotted line, all right? Not a solid line, a dotted line. And then don't ever forget to go back and put its equation on it. So there we go. We've got it graphed, we've got it labeled. And so far, you've done absolutely nothing to show any answers. Why is that? Well, this is a dotted line. This line doesn't contain any of the answers. So where are the answers? Well, the answers are either above or below. So let's go back to that visual. If this is greater than, then it's above the line. Okay? So greater than means we shade above. So this slope is a little bit different. It's negative, but still, if you were looking at the graph, this would be above the line. Okay? And there you have it. You have just graphed an inequality that was in slope-intercept form. So I don't see any questions, but if you have any, now's a great time to let me know. Put them in the chat or unmute and answer them with your voice. But we've only got like 2 more to go, so we're not going to do too much of this. So please, I'm really trying to go through this as fast as I can so that you're not sitting there watching a computer screen for too much longer. This next one is not in slope-intercept form. It is in standard form, which means we don't know the slope, we don't know the y-intercept until we get y by itself. So we got to have some good equation solving skills. And so hopefully you remember from lesson number 10 how to do this. You want to subtract 3x on both sides and get -2y. Now this inequality will stay the same and be greater than or equal to. Over here, don't add or subtract unlike terms. They must be kept separate. So -3x plus 2. Now we have to solve for y. So we want to undo the multiplication and divide everything by -2. So that's going to make this a 1 and leave us with the y, and this is going to be -3x over 2, and positive 2 divided by -2 is -1. So I'm getting a little bit closer. We're going to switch the sign to less than or equal to because we divided by a -2. Now, it's always a good idea to state the slope and y-intercept. At some point, you'll probably be good enough not to do this, but, as we're learning, it's good to take care of some things. Now, we got the slope, we got the y-intercept, but we got to think about some other things because it's an inequality. Because it's less than or equal to, and that's what it finished up as, we got to think about what type of line and what type of shading. So let's go back to those pictures. When it was less than or equal to, it was a closed circle and a solid line. All right, so that's more traditional. And less than meant that we shaded below the line. Okay, so maybe let's make some annotations to remind us that this is going to be a solid line that is shaded below. Well, first we need a line. So let's go ahead with the first point at -1, the y-intercept. Now we're going to rise 3 and run 2. This one's going to go up and to the right or down and to the left. But most importantly, it's going to be going up and to the right. So that means it's got positive slope. Don't forget to always label it with its equation. Okay? And now we want to shade this inequality. Well, we've got the line and we've got some answers. So some of the answers this time are on the line because it's solid, and the other answers are below the line because it is less than. Okay? So hopefully this is all kind of coming together and making sense. So now I reintroduce a topic that we learned in lesson number 11. Remember the vertical and the horizontal lines that we talked about. We did that quizzes. If you haven't done that quizzes yet, make sure you go back. You have 1 week left to do any makeup work. December 14th is the last day in the 5-week marking period. So we want to graph and shade the solution set for the following inequalities. Well, remember that an X is made with a V and then an upside down V, because this is a vertical line, right? And the Y lines are horizontal. So when we graph this vertical line, we want to do so at 4. But before I get there, I got to take a look at the inequality sign, which is just less than. So if it's just less than, that means it's going to be a dotted line, because it doesn't have that little line underneath. It doesn't have that equal to. So I'm going to go to 4 on the x-axis, 1, 2, 3, 4, and I'm going to put an open circle, because again, it's not equal to 4. It's just less than 4. And then it's a vertical line, so a dotted line that is vertical up and down the page, and then let's label it x less than 4. So I'm going to get this a lot. I'm going to get a lot of students that draw the line but then forget to shade. Okay, so here's my little reminder. Please remember to shade, even though it doesn't always tell you to. Now, what side of this are we going to shade? Instead of this being a above or below situation, it's a left or a right, because it's a vertical line. Well, let's put some common sense to this. If that's 4, then that's 3, 2, 1, 0, numbers that are smaller. On the other side of 4 would be 5 and 6. So we want less than. We want smaller. We want to shade this to the left. Okay? Left is less. And so there is the solution to the inequality x less 4. All right, less than 4. Last one, a horizontal line that is at -2. So I want to go on the y-axis to -2, but is it solid or dotted? Well, this time I'm going to ask the audience here, okay? All right, so this is a solid line because it has the equal to part. So I'm going to go with a closed circle and a horizontal line that goes across the page. Always a good idea to label it y greater than or equal to -2. So there we have it. Now, what side of this line are we going to shade if it's greater than? So the answers are on the line and above the line because it was shaded above. So there you have it, a lesson on graphing inequalities.